In this lesson, we are going to take a look at corner treatment. Corner treatment is a setting found inside of the structural member command. Now, before we look at corner treatment, I want to talk about the model we have on the screen. This model was created in an earlier lesson and can be found in your Working Files folder under the name Steel Frame Corner Treatment. The model on the screen does have corner treatment applied, and that corner treatment is per the default settings of the software. What we want to do is take a look at some of the other options available to us. I am going to edit the structural member 1 and select group 1, which is this light blue path here that you see highlighted on the screen. I am going to scroll down, and here is the corner treatment options. I am going to begin by talking about this apply corner treatment, which by default is checked. So if I zoom up on this bottom left-hand corner, a corner treatment is already applied to these two members of group 1. What I'm going to do is uncheck this box just so you can see what happens. I'm going to close out of the command, and there's the result. What we have is overlapping geometry. Basically, each member runs the full length of the path segment. Typically, that is not what you want. So I'm going to go back and edit the feature and put a check mark in the box. Now let's take a look at the corner treatment options. By default, end miter is selected, and if I close out of the command, this is an end miter where both members are mitered to one another. I'm going to edit the feature, select the second option, which is a butt joint, and this one's called end butt 1. I'm going to go ahead and select it, click the check mark, and this is the result. The horizontal member is butted up against the vertical member. Now, if you wanted the vertical member to be butted up against the horizontal member, that's a pretty easy fix. You simply go back and edit the feature, and instead of selecting end butt 1, we should have selected end butt 2. So I'm going to go ahead and do that and close out of the command, and there we have it. Now, I want you to notice that the vertical member has a straight cut, and that is by default. If I take a look at that option, we can see we have a simple cut here, and that's what we're seeing on the screen. However, if you wanted this vertical member, which is butted into the horizontal member, to be coped around the horizontal member, we do have that capability, and that is a cope cut. So I'm going to go ahead and select cope cut, close out of the command, and you can see how it's coped around the horizontal member. I'm going to go ahead and edit the feature one more time, put it back to a simple cut, and now let's talk about gap distance. This is the gap distance between segments or members in the same group, where this is the gap distance between segments or members of different groups. And this one is grayed out at this time because we're in group 1. I am going to change a default setting of 0 to 0.25, close out of the command, and you can see a gap distance of 0.25. And these are both members of group 1. I'm going to go back into the command, put the gap 1 distance back to 0. I'm going to scroll up and select group 4. Now this member here is part of group 4, and now notice we have the G2 available to us. This is the gap distance between members of different groups. This member here is from group 4. These two members are from group 1. I'm going to change that distance to 0.25, close out of the command, rotate it around, and there's a 0.25 gap distance. I'm going to edit the feature again, reset group 4 gap distance to 0, close out of the command, go to a dimetric view. Next, we are going to take a look at some of the options we have available to us for locating the structural members in relation to the path segments. If I zoom up on this upper left-hand corner, you will see all of these structural members are located based on a center axis of each member. Now, what if we want to change that? All we need to do is edit the structural member feature. And I want to work with group 1, so I do want to verify group 1 is selected. I'm going to scroll down, and I have an option for locate profile. Now before I select this, I do want to tell you as soon as I pick this option, it's going to quickly zoom up on this corner. So I'm going to go ahead and select the option, and there we have it. This is a weldment profile for a 2x2 by 0.25 square tubing. As you can see, it's located based on the center point. If we want to choose a different location point, as you move your cursor around, you can see different sketch points that we can locate to. So I'm going to go ahead and select this one here. You can see the view is updated. I'm going to close out of the command and zoom out a little bit so you can see it a bit better. And notice all of the structural members for group 1 are now based off of that sketch point of that profile. I'm going to go back into the structural member, select locate point again, zooms up on the same view. This time, if you want to select a different point, it's just as simple as selecting another sketch point. Now we do have another option, mirror profile. If I select this point, it will take that sketch profile and mirror it. And there you go. Go ahead and close out of the command, and the structural members are updated. The last item we're going to cover is taking a look at how to control the behavior of each corner individually. I am going to zoom up on this upper right-hand corner of group 1. All of the structural members of group 1 have a miter joint, as we can see here. Now, if we want to change this one corner specifically to a joint different than a miter joint, the way we do that is we edit the structural member, and notice group 1 is selected. I'm going to zoom up in this corner a little bit, and we select the dot. I'm going to go ahead and move this dialog box so it's a bit easier to see. And notice in this dialog box, we have the option of selecting different corner treatments, and it only applies to this one corner. I'm going to go ahead and select NBut, and notice how the preview is updated. All of the other joints for group 1 are a miter joint. It's only this one that is changed to a butt joint. And we can also set the gap distance for this one corner. Now, I'm going to put it back to a miter joint. Now let's talk about this merge miter trimmed bodies. This is not checked by default. If you recall, group 1 is made up of 5 individual structural members. If you would like the 2 structural members of this corner to be one structural member, then you would check this box. Now, why would we use this? For example, if you were taking one long piece of 2x2 by 0.25 square tubing, and you were slicing it at the joints, but not cutting it all the way through, and then bending into the shape that we see for group 1, that would be a good example of using this option. The last thing I want to discuss in this lesson is trim order. If you notice, group 1 is highlighted, where group 4 is not. Obviously, that's because group 1 is selected. But we have 2 different groups here. Even though we know this is group 1 and this structure members from group 4, we have 2 different groups. In this dialog box, they're calling this first group, group 1 of 2, and the second group, notice this is highlighted, group 2 of 2. I'm going to go back to group 1 of 2. Now this trim order basically tells the SOLIDWORKS software how you want the structural members trimmed. For group 1 of 2, the trim order is 1, so these would be the first items trimmed. And then in group 2 of 2, the trim order is 2, which is saying this would be trimmed second. Now, this is a really neat feature. What if we leave group 1 of 2 at a trim order of 1, and then change group 2 of 2 to a trim order of 1? Let's do that and see what happens. I'm going to close out of this. And notice something drastically happened on the screen here. I'm going to go ahead and close out of the command so it's a bit easier to see. I am going to zoom out a little bit, rotate the model around, and notice all 3 of those structural members were trimmed equally, basically all mitered together. Keep this in mind. If you plan on taking the Advanced Weldments exam, this may be one of the test problems.